Okay, so today we talked about proving triangles congruent using the side, 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 and the side angle side postulate. Okay, so the first postulate is called side, side, side congruence postulate. We're going to abbreviate it SSS. It says if three sides of one triangle are congruent to the three sides of a second triangle, then the two triangles are congruent. So when I compare these two triangles over here, what I see is MN is congruent to QR, MP is congruent to QS, NP is congruent to RS. So what I can see here is since I have three sides of this triangle that are congruent to three sides of this triangle, then I can state triangle MNP is congruent to triangle QRS. So these two triangles are congruent. Remember, this order that they name them is very important. Okay. Okay, so it says, does the triangle give enough information to use the side, side, side congruence postulate and explain? In this diagram right here, what I see is I have two pairs of sides that are congruent to each other. This middle side right here, JK, is shared between the two triangles, so I can actually mark that as the third pair of congruent sides. And then what I have here is I can use side, 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 and I would say three pairs of congruent sides. Okay? Looking at letter B, I see that I have two pairs of sides that are congruent. So this pair right here, this is marked congruent to itself because it would be the same for each triangle. I don't have enough information to say that XY is congruent to YZ. Now, if they told us that this was a midpoint, then I could mark it. But since I don't have that information, I would just say no, and we would need a third pair of congruent sides in order to use side, side, side here. Okay. The next one says use triangle ABC to name the angle included between the two sides. So what they're doing here, we might want to write down what an included angle is. So an included angle, this is the angle between two sides of a triangle. Okay. So when they give me two sides, so like AB and BQ, if I kind of mark them for you, here's AB and here's BQ. What's the angle that's between those two sides? Or the angle that's touching the two sides would be angle B. So I would say angle B is the included angle. Okay, if I change my sides then, and now it says I'm going to use that same side AB, but now I'm going to use QA. Well, how did that change it? Well, both of these sides are touching angle A, so angle A would be my included angle. Okay, if I look at the next one, I have BC and I have AC, and they're both touching that angle C. So angle C is my included angle. And then the last set, it says BQ. So here's BQ, and here's CQ, and both of these sides are touching angle Q, so angle Q is the included angle. Now, one thing that I noticed when I looked here is I said, well, AB and BQ, what letter do these two names share? They're sharing a B, so angle B is the included angle. AB and QA, they both have that letter A there, so angle A is the included angle. That's one thing that you can do to kind of help you pick out the included angle. On the next one, it says we're going to use the side angle side congruence postulate, and the side angle side congruence postulate says if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. Okay, so if I look, I see PQ is congruent to WX, and this side QR is congruent to this side XY. What they're asking is, well, what they're telling us is if I have the included angle, so the angle that's touching both of those sides, so included angle, if that included angle is marked on both of the triangles, then I can say these two triangles are congruent using side angle side. Okay, so number 3 says, does the diagram give enough information to use the side angle side congruence postulate and then explain? If I look here, I see XW is congruent to QR, XY is congruent to QP. This angle is touching both of those two sides. This angle is touching both of the two sides, so I would say, yes, this is the side angle side congruence postulate. We would say two pairs of congruent sides and the included angles are congruent. Okay, if I look at letter B, I have two pairs of congruent sides. I also have a pair of congruent angles, but when I trace these two sides, XY and WY, what would be my included angle for those two? It should be angle Y. Angle Y is not marked, so I would say, no, this doesn't work, and we would say we need the included angles to be congruent. Okay. On the next one, letter C, I can mark this shared side right here. I can mark PQ as a side. If I know this angle right here is 90 degrees, I can also mark 90 on the other side. So if I cover up one of the triangles, what I see here is that this is side, angle, side. Okay? And if I cover up the other triangle, I see it's side, angle, side. Okay, so this is going to be side, angle, side, and I could say two pairs of congruent sides, and the included angles are congruent. Okay, on letter D, I can mark the shared side right here, and what I have is these two sides are congruent to these two sides. I have a pair of angles that are congruent, but if I look at XW and this side XY, do I have the included angle? Is Y the included angle? No, because Y only touches XY, but Y does not touch this side over here. X would have to be my included angle, and I don't know that it's congruent to the other triangle, so I say, nope, I need the included angles to be congruent. Okay, we got a little bit into triangle proofs today. So just a review, a reminder, a proof is a convincing argument that shows why a statement is true. Okay, steps for writing the proof, it says we're going to list the given information first. This will be the first step every single time. Second step, it recommends that we mark our picture based off of the given information. Use the information from the diagram. We need to give a reason for every statement. So our reasons are going to be definitions or properties or postulates or theorems. Okay, list the statements in order, and what that means is I can't skip steps, and I can't put two steps into one. I need to put them in a logical order, and then end the proof with the statement that we're trying to prove. So when I look at this first proof here, it gives me some information, and then this is what I'm asked to prove. So the first thing I do is I copy down the given, and I say SQ, segment SQ is congruent to segment PM, and angle SQM is congruent to angle PMQ. And my first reason is always going to be the given. So any test or quiz, this point should just be an easy point for you. I copy exactly what's up here. I put it down here. The first reason is always the given. From here, I need to mark my diagram. So SQ is congruent to PM. So if I look, here's SQ and here's PM. I'm going to put little markings on them showing that they're congruent to each other. Then it says angle SQM is congruent to angle PMQ. So SQM is going to be this angle right here. It's congruent to angle PMQ, so this angle right here. What I would ask you then, is there anything else I could mark in this diagram? What I can do is I can mark this centerpiece because it's shared between the two triangles. It would have to have the same measure in both triangles. So since I marked it, I need to state it in my proof. I'm going to say MQ has to be congruent to MQ. And my reason is the reflexive property. Reflexive property just means I'm stating the exact same thing on both sides. Okay, so it's congruent to itself. Step 3 then, if I look at the two triangles, if I kind of cover up that top one, what I have here is I have side, angle, side. Okay, so, and then I have the same thing up here, side, angle, side. So I'm going to say triangle. I'm moving to my proof step now. QSM is congruent to triangle MPQ by side, angle, side. Okay. On the next one, I'm going to start by copying the given. So AC is congruent to EC. And then I'm going to say C is the midpoint. I'm going to abbreviate a little bit. Midpoint of DB. And this is going to be the given. Now I mark my picture. So I'm going to say AC is congruent to EC. Tells me that C is the midpoint of DB. So that means C is in the middle. And if C is in the middle, it really says that these two pieces would have to be the same. DC and CB are the same. So I marked it on my diagram. That means I need to state it in my proof. So DC is congruent to CB. And my reason was the fact that I had a midpoint. So I call this the definition of midpoint. I can't just say midpoint, I have to say definition of midpoint. Okay? Step 3 then, is there anything else I can mark in this diagram? I know that this angle here has to be congruent to this angle here because they are vertical angles. Okay, so I'm going to say angle ACB is congruent to angle DCE, and my reason is that vertical angles are congruent. Okay, notice I don't just write vertical angles, I actually have to state the relationship. Vertical angles are congruent. Okay, from here, if I count, I have 1, 2, 3 pieces congruent. If I look at my picture, this would be side, angle, side. It's marked the same in the other triangle. I'm going to copy down exactly what they have right here, and I'm going to say triangle ABC is congruent to triangle EDC. And my reason here would be side, angle, side. Okay, the last proof is a fill in the blank. So it says fill in the missing statements and reasons. It says CB is congruent to CE and AC is congruent to DC. They put it right here. My first reason should always be the given. From there, I need to mark my diagram. So CB is congruent to CE. They also tell me that AC is congruent to DC. So AC is congruent to DC. Okay. From here, they say angle BCA has to be congruent to angle ECD. So angle BCA is right here. I'm going to mark it congruent to angle ECD. And why are those two angles congruent to each other? Well, it's the same reason that we used up here in this proof. We're going to say vertical angles are congruent. They're always congruent to each other. Now it says triangle BCA is congruent to triangle ECD. And what are we using here? This is side, angle, side, side, angle, side.